In this video, we'll talk about another kind of class of mutations and then compare the effects of different mutations. So here I have the same template DNA as in the last example, but this time we're going to delete one of the amino acids in the template DNA. So this fifth base here, we're just going to completely ignore it and act like it just never got put there. So what I'm going to do is I'll rewrite the template DNA. And I'll write it kind of lined up in triplets to make it easier for us to do our transcription. So our new DNA will go TAC, which is unaffected, then C. Now there used to be an A there, but it's deleted, so now let's just go straight to C. The next one will be a C. Then the next is T, A, A, C, A, and then two T's, all lonely, without a third base to make a codon. Okay. So that's what our mRNA will, that's what our DNA will look like. If we transcribe that into mRNA, get, A, U, G, 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 A, U, U, G, U, U, A. And you'll see that the effect of a deletion, and the same effect is found if you were to insert a base, so say we inserted another base in this same region, the codons all shift. Right? This is called a Frameshift mutation. That's because how the codons line up all changes after that mutation. So while, the G here, that used to be the first base in the third codon, ends up being the last base in the second codon because they all have to get shifted down to form triplets. So now if we translate this into amino acids, you get MET, which is unaffected, and you get GGG, you get GLY, AUU, INE, GUU, Val, and then the AA is kind of like nothing, right? Because it needs another base to be a full codon. And you'll see that in the kind of three bases that, the three amino acids that made up this small polypeptide, all three of them changed, including kind of not having a stop codon, because of this one deletion, which shifted all the codons over by one, so to speak. So these are called frameshift mutations. They happen when you delete or you insert a base. Everything kind of slides over, and this, dramatically changes the composition of the polypeptide. So this has a dramatic effect on the shape of the polypeptide. So it has a dramatic effect on the functioning, what that protein can do. And these mutations often will end up inserting a stop codon somewhere along the way. So yeah, frame shift mutations, kind of where you insert or you delete a base, generally wreak havoc on a protein, which isn't to say it's good or bad, but it's a dramatic change, usually in the shape. And so again, we can compare these to silent mutations, which really have no effect. Missense mutations, which can have some effect, and just a side note, the severity of the missense mutation really depends on how much the polarity of that amino acid changes. So if you're going from a non-polar amino acid and it's a missense mutation to a charged one, that's obviously going to have a larger effect on the 3D shape of the protein, most likely, as compared to a missense mutation that replaces a non-polar amino acid with another non-polar amino acid. And our third type, nonsense mutations, are often radically change the protein by kind of just cutting it short, so it never is even the same size as it used to be. And those are the basic mutations that we'll be talking about for our course.